Solve for n in each of the following, show working. So here we're doing a subtraction. We can see the n is here, so we only need to look at the top left elements. So -8 take away 4n must be equal to 4. If we now add 8 to both sides of this equation, we get -4n is 4 plus 8, which is 12. Divide both sides by -4, and we'll end up with n is equal to 12 divided by -4, which is -3. Over here we have a multiplication to do. Note that n is actually in the bottom row. So doing our usual thing, turn the row up on its side. We're multiplying the column, so 5, -4, 9. And remember we multiplied those, so that's going to give me 15, -4n, and -45. So if we add these together, the 15 take away 45 gives me -30, and then I've got -4n. So -30 minus 4n must be equal to the bottom times the column would give me this bottom number here, so that's equal to -22. Add 30 to both sides of the equation, -4n is going to be 8. Divide both sides by -4, and we get n equals -2. You could of course do this by some sort of trial and improvement type method as well. Note also that this was on the calculator paper. So we have the calculator, and given that, we can certainly, when we get to equations, solve them using the calculator. So that's solve -8 minus 4. You can use n, but it's best to use just x here because you don't have to then tell it you're solving for n. Equals 4. And that would give me the x is -3. So when you get to the equations, you can solve them on the calculator if it's calculator assumed, obviously. You can't if it's not. And would it actually have solved the equation involving the matrices to start with? I'm going to try that. I'm not sure that it actually will, but let's give it a go. Let's actually try it with this right hand one here. I might need to just clear off some of my scribbling so I can see the numbers. So, action, advanced, solve. And then we start off with a 2 by 3 matrix. So, all my matrices are here. So let's make a 2 by 2 and then give it an extra column. So that's going to be -3, -6, -7, 3, let's put x in for the n, and -5. And then we have just a column matrix with 3 rows. So that's going to be 5, -4, and 9, and equals, so now we just want a column matrix with 2, so that's -54 and -22, and see if it does it. Never tried this before. And wrong argument type. So no, it won't do that. You're going to have to do at least some of the matrix work yourself. And that's good to know because it means you won't waste time typing all of that in.